Welcome back to a new video lecture, and here we discuss a problem related with the kinematic method on frames. So here it is mentioned that collapse loads is acting on the frame ABCD as shown in the figure determine the plastic moment capacity of the section required. Assume the same section is going to be used throughout. Okay, so our final aim is to calculate the plastic moment capacity. So in this given question it is mentioned that this ABCD UDL with the magnitude 10 kilonewton per meter is acting, and over the span this AB portion, that is 5 meter span, and for the BC portion it is 20 kilonewton per meter UDL is acting. And it is also mentioned that these loads are collapse loads, so there is no load factor is mentioned, so we can conclude that the given load is collapse load. So using this magnitude you can calculate the plastic moment capacity. So first of all, you need to calculate the beam mechanism, then sway, then the last one is combined mechanism. So moving on to the beam mechanism, if you consider this AB portion, you can observe that actually this figure it is going to be in this way, means it's a propped cantilever actually, if you observe clearly, with the UDL is acting. So already we discussed that case, that is if a UDL is acting over a propped cantilever beam, the plastic hinge will form at a distance of 0.414 L. Okay, so that is shown here, and the remaining distance it is going to be 0.586 L. So this L represents this span length, that is 5 meter in this case. Okay. So once again repeat, in this case you are considering this AB portion, and this AB portion will act as a propped cantilever portion. So in that case, if a UDL is acting, the plastic hinge will form at a distance of 0.414 L from the simply supported end. So you can represent that by this, so at this point there will be a hinge MP, and at this point also there will be MP, hinge will be forming. So this is a simply supported and there is no hinges will be forming at that support. So then you can mark down this theta 1 and this theta 2 rotations, and if you equate those, or if you consider these triangles, you can equate in this way, that is 0.414 L theta 1 equal delta, that is equal to 0.586 L theta 2. You are taking this both triangles and relating this delta values, and finally you get a value of theta 1 equals 1.415 theta 2. Then equating the internal work done and external work done. So if you observe this MP theta 1 plus theta 2 plus MP theta 2 equals this external work done, that is magnitude is 10 multiplied by total distance, it is going to be 5. Then the average distance, that is going to be delta by 2. Okay, so this case also we already discussed regarding this UDL. Okay, 10 multiplied by the total span distance multiplied by the displacement, the average displacement that we are taking in this case. So if we equate those values by substituting this theta 1 with this, replacing theta 1 with this 1.415 theta 2, you will get a MP value as 21.449 kilonewton meter. So this is the first case of beam mechanism in the portion AB. In the similar way, you have to consider this BC portion also beam mechanism. So that is shown here, the beam mechanism for BC portion. So the plastic moment will form at these points B and C, and also under the load. In this case, the magnitude of load is 20 kilonewton per meter. So under that load also. Okay, so in this case, it is not propped cantilever. Actually, both the sides, both the supports are going to be fixed if you check out in this case. Okay, so the values is, or if you equate, it is going to be MP theta plus MP theta plus theta, then again MP theta equal to external work done 20 multiplied span distance 5 in this case, then average distance it is going to be delta by 2, and if you equate MP equals 31.25 kilonewton meter. So this is the second case regarding the beam mechanism. Then coming to the next one, that is sway mechanism. So in this case, we are only considering that 10 kilonewton meter. 10 kilonewton per meter only we are considering for sway mechanism. There is no role for this 20 kilonewton per meter in the case of sway mechanism. So usually the hinges will form at the supports at B, then C, then again D. Okay, why it is not going to form at A? Actually, in this case, it is provided as hinged support. Okay, that's the reason why. So if you consider this MP theta, then plus MP theta again plus MP theta equals 10 multiplied by 5 multiplied by delta by 2. And if you equate those values, MP equals 41.67 kilonewton meter. So that's the case regarding this sway mechanism. Then coming to the next one, that is combined mechanism. So in this case, there is a delta 1 and here delta 2. Due to this delta 1, two loads are acting. So that's why delta 1 and delta 2 is observed here. So in this case also, the hinges are forming at these points under this load, then again here, then at this point. So 3 plastic hinges. I already mentioned that why it is not forming at this support. Since there is, if you consider in this way, after rotation also, this position, it is going to be same. Okay, so in the previous lecture we already mentioned that thing. So MP theta plus theta, okay, then again MP theta plus theta, then the last one MP theta. Then if you directly multiply those values, that is the magnitude of this side value, it is going to be 10 multiplied by 5, again delta 1 by 2 plus 20 multiplied by 5 multiplied by 1 by 2 delta 2. Then if you equate those values with the theta values, if you consider, you'll get the value of MP is going to be 50 kilonewton meter. And if you compare those values of MP regarding this beam mechanism, then sway mechanism and combined mechanism, the maximum value of plastic moment it is going to happen, the last one, that is 50 kilonewton meter. So that's why the final plastic moment value is going to be 50 kilonewton meter. Discuss another problem relating with this collapse load. So determine the collapse load WC for the frame. So in this case, our aim is to calculate the collapse load WC. So we need to calculate all those mechanisms. We need to consider all those mechanisms, beam mechanisms, sway and combined mechanism in this case also. So a frame ABCD is given here and the supports A and D are going to be fixed, and a load W is acting in this way. Okay, and in the horizontal and vertical directions also loads W are acting, and also the span also mentioned here. And the plastic moment values, it is not constant throughout. For this AB it is MP, and for BC it is 3 MP, and for CD it is MP. So that's the given conditions. So in this case, for BC we need to calculate this beam mechanism. So in this case you need to calculate for actually beam mechanism 2 cases in this case. Okay, first of all you need to consider under the first load W, then after that you have to consider under the second load W, the plastic hinges. Okay, so if you consider under the first load W, that is at a distance of 2 meters from the support B, so the figure will look in this way, that is MP at B, 3 MP at the under this load W, then and C it is going to be MP. Then if you consider those values, if this W is acting, then the deflection is going to happen at this point, it is going to be delta 1, and at under this it is going to be delta 2. Let us take the cases, and the angles are represented theta 1 and theta 2. And if you equate those triangles, if you consider those triangles, 2 theta 1 equals delta 1 equals 4 theta 2, that is this distance is 2 and this distance, remaining distance is going to be 4. Then theta 1 equals if you equate those values as theta 1 equals 2 theta 2, then delta 2 equals 2 theta 2. If you are taking this, considering only this small triangle, then delta 2 equals 2 theta 2. Then if you equate those values as, that is mp theta 1 plus 3mp theta 1 plus theta 2 plus mp theta 2 equals WC multiplied by this delta 1, it is going to be 4 theta 2. Okay. Then WC multiplied by 2 theta 2, that is the second one. Why we are taking this theta 2 such that all the terms is here also we arrange in terms of theta 2 and we can cancel it easily. So finally we get WC equals 2mp. WC equals 2mp. Then similarly, we are considering this beam mechanism, second mechanism, that is under the load, the second load W. So such that the deflections are happen in this way, delta 1 and delta 2 respectively. The procedures are very same. That is, if you consider this triangle, that is 4 theta 1 equals delta 2 equals 2 theta 2. Okay, just considering those triangles. Then if you equate, that is mp theta 1, then 3mp multiplied by theta 1 plus theta 2, then mp theta 2 equals WC multiplied by delta 1, that is 2 theta 1, then WC multiplied by 4 theta 1, or in this case it is delta 2. Delta 2 is represented as 4 theta 1, and finally you will get a value of WC equal to 2mp. So that's the case regarding beam mechanism. Then coming to the sway mechanism, in this case the plastic hinge will form at each support surface. Then if you equate those values with external work done, that is WC multiplied by 3 theta. How you got this WC multiplied by 3 theta? From this triangle. If you consider this value is 3 and this theta, then this value is delta, then delta equals, or theta equals opposite side by adjacent side, then delta equals 3 theta. Then you will get a value of 1.33 mp. Then the combined mechanism, coming to the combined mechanism, if you observe, first of all you take under the first load, that is here there will be a value mp, here it is going to be 3 mp. Okay, actually in this case, this BC portion, the plastic moment value, it is going to be 3 mp. That's why we are taking 3 mp. Then at this point we are considering mp. Why? If at a joint, we already discussed all those terms, if here 3 mp and here mp, the smaller value will consider that particular joint. That's why we are taking mp and here also mp. Then directly equate, and already we mentioned why we are not taking this plastic hinge at this support. Okay, there is no change. Okay, that's the reason, there is no change for this member to happen through this load W. Okay, then directly equating the triangle, or considering these triangles and directly equating, you will get 2 theta 1 equal delta 1 equal 4 theta 2 by taking these triangles. And in this case there is a delta 3 value for here, and here it is delta 1 and here it is going to be delta 2. So 2 theta 1 equals delta 1 equals 4 theta 2. Then delta 2 equals considering this triangle. Then delta 3 equals considering this triangle. Okay. Then directly substitute or equate this external work done and internal work done, that is mp theta 1 plus 3 mp theta 1 plus theta 2 plus mp multiplied by theta 1 plus theta 2 plus mp theta 1 equals WC delta 1 plus WC delta 2 plus WC delta 3. Substitute each values for this delta 1, delta 2, delta 3, a common term. And finally, if we equate WC, it is going to be 1.33 mp. Then one more mechanism for this combined mechanism itself under this load W, the second load W. So here MP, here 3 MP, here MP, here also MP. All the procedures are same, and finally you have to equate those values as external and internal work done. MP theta 1 plus 3 MP theta 1 plus theta 2, then MP theta 1 plus theta 2, then plus MP theta 1. Okay, so don't get confused about where to substitute this theta 1 and theta 2. Okay, so why we are taking this here also theta 1 and here also theta 1? Actually the rotation happens is considering same, and but under these conditions the loads are not symmetrically acting, so that's why we are providing here theta 2 value. And if this is theta 1, obviously here also theta 1, and if you consider this theta 2, then here also it is going to be theta 2. The rotation happens in this way. Then just substituting those values, and finally you'll get a value of 1.556 MP. Okay, then finally our conclusion is to calculate this collapse load. So in this case it is concluded that 1.33 MP. So out of these values, if you compare, if you consider from the starting beam mechanism, the WC is going to be 2 MP, and then coming to the second, that is sway mechanism, the value is again reduced to 1.33 MP. Then coming to the combined mechanisms, the value is going to be 1.56. So out of these three values, the smaller value is going to be 1.33 MP. That's why we consider this collapse load as this 1.33 MP. So that's the final answer for this particular question, and I hope the section is clear, and with this we wind up today's section. Thank you.